Welcome to Risk Roundup. Nations, its government, industries, organizations, and academia, in short referred to as NGIOA, are going through the next wave of digital disruption that is driven largely by artificial intelligence, in short referred to as AI. There are numerous reports that artificial intelligence has convincingly penetrated into general applications across NGIOA, from medical diagnosis to stock trading, robot control to remote sensing, thousands of artificial intelligence applications have already been getting deeply embedded in the infrastructure of individuals and entities across NGIOA. These are just some examples. As we go forward, entities across NGIOA will surely go beyond basic tasks like computing data and collecting metrics to developing more intelligent algorithms to strengthen some of the most important operational, tactical, and strategic technologies and initiatives. This is expected to impact and change not only technology, but also business, management, and governance models in cyberspace, geospace, and space. So, what does all this mean? It means that if the decision makers across NGIOA are not thinking about artificial intelligence, machine based learning, deep learning, and intelligent machines now, then they run the risk of their initiatives, products, services, and businesses being undoubtedly disrupted in the coming years. Intelligent machines are here, and the question is whether we, the individuals and entities across NGIOA, are prepared for what is to come. To discuss this further, I'm delighted to welcome Marc Stein, CEO of Underwrite and Principal at Artificial Intelligence Capital Management. Welcome, Marc. We're delighted to have you on Risk Roundup.
Thank you. Very nice to be here with you.
Wonderful, Marc. So it seems that intelligent machines are already here, Marc. Are individuals and entities across NGIOA prepared for what is to come?
Well, yes. I think that it's important to specify what we mean by artificial intelligence in terms of how it's actually being applied in production today. There is no generalized artificial intelligence. When we talk about artificial machines, it's somewhat of a misnomer, or intelligent machines is somewhat of a misnomer. The way that AI is being used today is in very, very narrowly focused areas. So particularly in, say, visual recognition, speech recognition, captioning, things of that sort. It's playing a key role in the development of autonomous vehicles. But these systems are in no way thinking systems. They simply do a simple task which would take a human being more time. So, for instance, when we talk about the use of AI in banking, there's really very little AI actual implementation in banking. What you'll start to see more of is the development of customer service bots, where when you have a chat session with your bank and you're asking about your balance and a return check, that much of that will be mediated initially by a bot. This is an implementation of artificial intelligence, but no one should confuse the chat bot with an intelligence such as possessed by a human being.
I read some reports that there are some companies who have developed AI-based trading, and they have actually tried out AI-based trading successfully. So
AI which?
AI-driven trading, stock trading.
Well, you have a lot of funds that are doing high-frequency trading based upon algorithms. These are not artificial intelligence algorithms. These are simply statistical algorithms. So the main advantage of high-frequency trading is that it can evaluate, thousands of data points in a portion of a second and make a trading decision. but these are not really value-driven determinations. These are high-frequency trading systems are looking for arbitrage opportunities in disparity between two exchanges. All right, they're looking for very, very small incremental differences. So I would hesitate to call any of those things artificial intelligence. We do use machine learning in what we do for finding arbitrage opportunities in peer lending assets, and that's a particularly good application. So you do have the use of advanced algorithms and more advanced computer techniques used particularly among hedge funds, but I would hesitate to call it artificial intelligence. Goldman Sachs has been doing some work with deep learning in the financial services area. It's not at all clear that anything has actually been deployed. You know, artificial neural networks were tested pretty extensively in the mid-90s in the banking industry. Countrywide did a very large test for mortgage underwriting using ANNs. The determination really was that it's not ready for prime time. It really didn't work. It worked well enough in terms of efficacy, but it wasn't ready for a production rollout because ANNs were simply too brittle and computationally too intense for the state-of-the-art in computer equipment then. What's really changed is with deep learning is not so much that the technology has improved, although it has, but that the computers have improved and the cost of computing has come down. So now you can throw the computational resources at the problem that you could only dream about in the 90s. So we are seeing more progress in the deep learning space today than we saw in the 90s. But if you go back and you look in the literature, you'll see a lot of stories that came out about how AI was taking over the mortgage space and the banking space in 1995. That was somewhat preliminary. It never happened. Major banks today don't use most of these technologies. I'd say that 99.9% of major bank underwriting is done in the traditional linear regression model using FICO scores and debt-to-income ratios.
Yes, but there is no way, Mark, to know exactly what is the state of progress and development when it comes to private corporations, because these are very private and proprietary technologies, and they're not going to share all the details. But one thing remains sure is that the digital global age, massive data explosion, cloud computing, cybersecurity, cyber warfare, machine learning, and rise of intelligent machines, and more, that combines to make progress, development, human survival, and sustainability a very defining challenge of our time. So from your perspective, I mean, as you said, we are still into the artificial narrow intelligence phase, and we haven't reached the artificial general intelligence. We don't know when we'll be, reaching there, as you are saying.
It won't occur.
Yes, I mean, it will happen, but
No,
there are conflicting reports. I mean, there are some places you read that, that has already occurred. Some places we read that, like you are saying, that, we are still in the artificial narrow intelligence. So we'll wait and see. But the fact is that there is a lot of progress and development happening, which is, promising in a lot of ways, but it also is causing a lot of concern. But across which components, that is government, industries, organizations, and academia of nations, you see that we have already achieved artificial intelligence given proven applications so far. I mean, we have been having some sort of use of artificial narrow intelligence for so many years. We have seen that in our computers and our smartphones everywhere. But which are the major proven applications that you can talk about, that these are some achievements that we have achieved?
Well, the one that's probably gotten the most publicity over the last year was AlphaGo, which was Google's effort to create a Go machine that would be able to beat a human Go champion. And it was a great accomplishment, but again, within a very, very narrow area. So to me, what it really represents is that Google spent $500 million and a massive amount of computational resources, hundreds and hundreds of engineers, to build a system that could play a single game. And they were able to effectively build a system that performed very well. But in terms of, is this an artificial intelligence? Well, this AlphaGo couldn't play checkers, couldn't play chess. It certainly couldn't underwrite a loan or diagnose cancer. All it could do is simply recognize board states and calculate the best path forward from a given board state. To me, from an academic sense, it's an interesting accomplishment. I don't know that it's a great use for $500 million. But I think that really points out where the problem is. So in the popular media, there was a great deal of discussion that AlphaGo meant that human beings were going to be replaced by computers, because finally this very strategic, difficult board game could be played better by a computer than a human being. It's a very, very long jump to the notion that computers can replace human beings for thought-intensive products from that. And that's really the most advanced case.
It is like this, Mark. When a child is born, it takes a lifetime for that child to learn, all kinds of things. 1 year they learn different things, in 2 years, 3 years, 4 years. So I think that $500 million you're talking about, a child is born, which is, not human. And it is going to take many, many years before it's able to learn everything. So to expect that and to hope that, it learns everything in just few years, it is probably, unrealistic. So we are onto something really interesting, but it's going to take many more years before we are able to teach everything to that, child.
I'd like to point one thing out, and it's an interesting comparison when talking about children and computer. A child has over 1 billion neurons.
Yes.
A child has trillions of neuronal connections. So each of those neuronal connections can hold weight values. Additionally, each cell in the human body has 2,500 protein encoding genes, each of which can hold expression values. There is no way that you can construct a computer out of silicon that can rival the construction of the human brain. So the learning capability of a human being is infinitely greater than any silicon-based computer. You can argue that you could eventually build general artificial intelligence using cloned neurons. We do know today that we can clone neurons in vitro and that they will clump into functional elements. They'll start forming connections. So it would be possible to build at some point in the relatively distant future a artificial brain, and by increasing the number of neurons, you could potentially come close to the performance of a child. Right now, the performance of these computer systems is much, much closer to the performance of a flatworm than a human child.
Yes.
So we're very, very far away from general artificial intelligence. My personal belief is that there are a great many constraints that prevent it from happening ever. Most likely the construction, the difference in construction between human neuronal systems and computers. It's an interesting metaphor to talk about, neural networks as modeled on the human brain, but it's a very cursory similarity.
You said there are some constraints that prevented the further advances. What are those?
Um, well, the nature of a digital computer is inherently much less flexible than the way that a human brain works. The degree of parallelism in a human brain is unthinkable in computer terms. So the what a human being starts with is uh, an ability to absorb and retain a much greater information than computer memory allows for. One of the biggest instances that you run into when you try to talk about artificial general intelligence is what we call common sense. The notion of connections between meaning and the context of things. And it's an intensely difficult problem from a computational standpoint. But just explaining that a cat, we all know what a cat looks like. But if you're trying to explain to a computer what a cat looks like and you happen to show a bobtail cat, the computer doesn't recognize a bobtail cat because in all the pictures you've shown, the cat had a tail. So, but a human being immediately recognizes that a cat without a tail is still a cat. That's an intensely difficult problem from a computational standpoint. So, finding all these use cases and building a sufficient understanding of the world around us is something that we're at an incredibly preliminary stage. There was a project called the Psych Project that ran for a number of years. It was heavily funded by the government, and it was an attempt to create a rule set around common sense. I think they discovered that common sense is a really, really big topic.
Yes.
And codifying it all is intensely difficult. And until you have that base of understanding that we all take for granted, we're not going to see this large scale implementation. What we will see, and I think this is a really important part, is that the traditional way that we evaluate risk or make decisions deals with taking a complex situation and reducing it to as small a number of predictive variables as possible. Because we tend to approach these things by defining a set of rules that then go into a matrix. So if we look at loan underwriting, which is a key implementation, today a bank looks at the FICO score or the credit score of an applicant. They look at the debt to income ratio. So how much debt does a person have relative to their income? They look at the count of inquiries made against a person's credit file. And they look at the repayment of debts in terms of 30-day late trades, 60-day late trades, 90-day late trades. So those are the 4 points that go into modeling a credit determination. And they use a combination of exclusionary and inclusionary rules. So, for instance, the bank may say, well, if someone's debt to income ratio is greater than 35%, we don't want to loan them more money. We think they're overextended. So that's a hard cutoff. Then there's a series of ranges. Well, if their FICO score falls between 680 and 720, here's the rate as long as there are no 30-day late trades and no 60-day late trades. So that's how underwriting works. And it's pretty much universal, not just the United States. What we find today, though, is when we do loan underwriting at Underwrite, there are 2,400 credit attributes that we're looking at, not 4. And the methodology that you use for evaluating 2,400 attributes is radically different than what you would do with 4. you can no longer create a rule set. As a matter of fact, you can't even create a rule set if you have 16 predictive variables, because when we create a full rule set around 4, we generate about 31 pages of rules. Now, imagine if you had 400 or 4,000. It simply isn't workable to use this kind of expert system, rule-based, human-engineered, or algorithmic approach if you want to incorporate those additional data points. Now, we are only looking at credit attributes from a bureau. But if you're not looking at a regulated area like lending, and you're looking at something like marketing, right, where you don't have all the legal constraints as to the use of data, you want to look at things like their Twitter stream, their Facebook postings, how long they've had an email, how many emails they send. You want to look at actually hundreds of thousands of data points. And you need a different methodology for looking at those hundreds of thousands of data points. And machine learning gives us the methodology necessary for coping with the data overflow that is occurring today due to the fact that we live more and more of our lives in an electronically mediated environment. You know, we shop online, we communicate online. Email has replaced the postal service. We bank online. Well, all of this generates data. Now, in the banking space, most of this data can't be used. Right? It's you can't decline a loan because of something somebody posted on Facebook. There's all sorts of federal laws that you would be breaking. It also wouldn't be effective from a lending perspective. What people post on Facebook or how many friends they have is not predictive of whether they'll repay a loan or not. So there are a lot of legal and regulatory constraints when you get into something like lending. But the big issue today is how do we bridge the gap between the methodologies we use for evaluating risk and making decisions and the amount of data that we're generating. And we should be clear, when your loan is being decisioned in a bank, more than likely it's running through a computer, but the computer's looking at these 4 variables. So when we make the transition to machine learning, all we're really doing is saying the computer's now looking at more variables. The computer is still constrained by the same rules as a human underwriter would be, or the bank when they were using an older technology.
Do you expect those rules to be like for long?
That you broke up a little bit.
Yeah. Do you expect the rules, the constraints, to be like that for a long time, the regulatory constraints?
Oh, yeah, the regulatory constraints don't change because of the technology. The technology needs to change to adhere to the regulatory constraints. For instance, in the United States in lending under FCRA and ECOA, which are two, long-standing regulatory structures, you cannot make a loan decision based upon anything like race, religion, age, color. You also cannot make a decision that you can't explain to the customer. So if you say to somebody, I'm not loaning you money, you can't say, well, my computer said I shouldn't loan you money. You have to say, well, I can't loan you money because you owe too much currently, or you've had 4 late payments in the last 2 months. So, you have to give a reason that they can understand. That's a law. Now, that's not going to change. So if somebody develops an algorithm that's highly effective, but is a black box and can't explain to someone why they were declined, you can't use it for lending in the United States. It's that simple. There's no reason why that would change. The law exists for a perfectly valid reason. And I don't think anyone really would want that to change. So no, I don't think that's an issue. It's the same sort of thing. You know, people have raised the question of, if you have an autonomous car and it has an accident, who's at fault? Well, that's not really an unsettled area of law. The car is registered to an individual. They crashed their car. Now, if they want to sue the manufacturer of the car for a defect in the autonomous driving system, then that's going to be resolved through the legal process. And that's the way it should be. So this isn't really some kind of massive change that's occurring. There's a structure for doing this. You know, somebody said to me, well, what happens if you're driving your self-driving car and it goes too fast and you get a ticket? Can you get out of the ticket? No, you can't get out of the ticket. You're in the car and you're the licensed driver. So the other aspect is that when you design an autonomous car, one of the constraints that you need to work with is you have to obey the traffic laws. So you can't have an autonomous car that goes through red lights because it'll get you there faster. So
it's
the
just
rules don't change.
the same human environment. That's what you're saying, right?
The constraints of the human environment are
It's
something that has to be applied to the machines. No one is going to give an exemption to an artificial construct to break the law because it's made out of silicon.
That makes sense. That makes sense. So, Mark, we talked about the loan underwriting, and before that, you talked briefly about some other financial processes. But where else do you see the role and processes of financial institutions that are now being performed by intelligent machines? I mean, I heard that the research analyst role in the asset management industry is now possible to be performed by artificial intelligence. So where else do you see this happening?
Well, actually, I've had a lot of hedge funds and investment banks ask me, really. I was just at an AI conference in New York last week, and I had a number of people from funds and investment banks say, hey, we'd like to apply, more intelligent algorithms in research, right? They're not doing it. They're talking about that they'd like to do it. Right, and these are really leading funds and banks. So I think that what is actually going on is that there are additional tools being developed that further empower the researcher or quantitative analyst to do more work more effectively.
So it's not to replace, but to
it's not by any means to replace. It's to increase productivity. Now, you can argue that if you double the productivity of a researcher, does that mean that that researcher can now take the place of two researchers from the past? So there could be an effect in terms of staffing levels, but that's a far cry from the idea that complex financial research is going to be performed by an algorithm. The problem with applying algorithms to financial markets is that financial markets are very, very complex. I mean, we deal with loan underwriting in the consumer space. It's a very simple kind of problem. Our typical client is looking to decide whether they should give a loan for $500 or $1,000 to somebody. Well, economically, they can't really underwrite by hand for $500 loans. They see hundreds of requests a day. So they need to automate that process. On the other hand, I had somebody ask me about airplanes. They do airplane finance. Right? So they finance the purchase of a $50 million airplane. And they want to know, should they be using an algorithm? And the answer is like Well, you can use an algorithm as a sanity check. You can use it to help your underwriter. I personally write these algorithms for a living on a daily basis. If I were going to put $50 million in play, I would want a person who'd been doing it for a long time to make the final decision and not assume that an algorithm has all the data points that it needs to make a correct
So it's
decision.
more like having tool or using algorithms as a tool to get more intelligence, but the decision maker still remains the humans, right?
Absolutely, and I'll give you another example. We do a lot of work with cancer research. One of the things that we do is we look at RNA microarrays. So we look at the expression levels of all the genes in a cancer diagnosis. So the traditional model is to look, say in prostate cancer, at 13 genes as biomarkers. And what we found was by looking at 13 genes, the standard Keogen prostate panel, the algorithms had about a 73 to 75% accuracy. By looking instead at a larger group of common tumor suppressor genes, we saw an 85% accuracy. But by looking at all 2,400 protein encoding genes, we got a 98% accuracy. So we know that this idea of looking at more data and not necessarily focusing on the assumptions that the scientist brings into play is very helpful. Now, where you go from there, though, is that once you've found that a model is highly effective at predicting cancer, that's fine from a diagnostic standpoint. But if you want to better understand how to prevent the cancer or why the cancer is occurring, you need to dig deeper. And so we then run a process called information gain theory on the models, and we look to see what are the genes that most drive the correct decisions. Now, what you'll find when you do that is when you start looking at those genes, you'll find that a subset of the most predictive genes are predictive after the fact. They're predictive in that they're the body's response to a person having cancer. So if you're trying to determine, does this person have cancer, this is a highly effective way to do it. But if someone has, say, elevated gene expression for PTEN, well, that's not really telling you anything other than that they probably have cancer. It's not telling you why they have cancer. So this is where a human then needs to look at what do we know about the genes that we've identified as being predictive? And can we separate out the ones that are predictive because they are tumor suppressors and find new genes that weren't in the past associated with prostate cancer? And does that give us a path to a new target where we can deliver drugs? So this is a good example of where machine learning can revolutionize cancer diagnosis and research, and is doing so.
But it's very complex. Mark, it's very complex because if you look at it, sorry, there was as we advance in genomics and we have more details about the human genome, and as we progress, and just like how when we go to doctor for a checkup, they would order blood work or all kinds of diagnostic tests. Maybe we'll reach a point where the doctors will routinely order the human genome analysis, personalized everybody's genome analysis, that where do we stand, what kind of genes we have, which are the dominant or suppressant. That is one factor. So when we have the genome data of every individual available, then using the artificial intelligence, it would be much more easier to pinpoint what kind of genes humans have, and under what conditions. Now here the environment also will play a role, because it is not just about having genes, but also what are the trigger factors, what are the environmental factors that are going to cause the genes to express. The fundamentals of gene expressions will also come into play. So if we can, I'm absolutely sure that we will be able to advance and progress to a stage where algorithms would be able to quickly understand what genes humans have, any individual has, and which are the genes that are likely to cause cancer, and what is the environment in which they are located, and what are the environmental trigger points that they have that would come into play, and that would probably give rise to cancer. So you are absolutely right, and you are on the right path, where we will be able to come up with an effective way of diagnosing human cancer. So I see that possibility happening. That, but apart from that, where else do you see algorithms or artificial intelligence playing an effective role when we talk about healthcare in general and hospitals and medicine that would benefit from machine learning?
Oh, a great many things. I would just mention, as to the last point, that the impediment to using full genomic scans and gene expression for everyone is purely an economic one. The cost today is about $1,495 to do a scan on an individual. And that is assuming that you submit at least 24 samples. So it's still a pretty big ticket item.
At this point, as we go further, just like having TV,
Technology
they
will
were very expensive, but then the price will come
when
down.
it gets down to $100, I think you'll start to see a fairly routine implementation where a sample will be sent off to a lab for sequencing, and we'll get gene expression and proteomics and a much richer understanding of individuals' biology. In terms of other implementations in medicine, there's a huge amount of data that's generated in medicine, just chart data and sensor data, and all of that can be utilized to improve delivery of services and prediction of outcomes. We worked on a project in which diabetes patients we looked at hospitalizations of diabetes patients, and we were looking at, well, how can you prevent recurrence of hospitalizations? And we found, just in the chart data for these patients, some strong indications that there were things that the hospital can do differently in terms of how they segment their patients, which patients should be scheduled for more intensive rehab work, that there are a number of things that the hospital could do that would reduce the readmission rate. And even common sense things like, well, if you take this cohort of patients and you extend their initial hospital stay by 2 days, you can eliminate this portion of the readmission. So it's a strong economic incentive for the hospital to, in fact, do what seems counterintuitive, which is to provide additional services or additional care to an individual who could theoretically be discharged because it costs less in the long run. Yes. So I think that there's, and this information was not something that was hugely complex to derive, but it's one data strategy among many. So by taking an approach of, we're looking at a vast amount of data and we're trying to make sense of it, we discover these trends that are very, very useful.
Yes.
I think cancer diagnosis itself will make a shift to being based on genomics. I think that's happening already. That's going to just accelerate. If you look at back to prostate cancer, a trained, highly skilled pathologist looking at a frozen section has maybe an 80%, 78 to 80% accuracy of actually identifying cancer in the sample. We can do considerably better by looking at gene expression levels. That hardly means that there's not a place for pathologists,
Yes,
but
no, absolutely, absolutely. I mean, all this genomics and all this are very good advances, and we would get really accurate diagnosis. But I think to be able to beat cancer, to win the war, like so many people say war on cancer, we need to also have focus on the environmental toxins, because that plays a very important role. Just focusing on the diagnostic is not going to help us win the war on cancer. But again, that's such a complex topic. There is so much that needs to be talked about, that I think we don't have that much time to just focus on the cancer. But let's talk about, Mark, the what I'm hearing these days is that there are a lot of reports that artificial intelligence that includes an emotional component is in the process of being embedded into everyday applications in the coming years, giving rise to emotionally intelligent machines. So it's like effective computing. Can you explain the need for that, and where do you see the benefits? Because I mean, it seems very interesting that our machines, robots, or any artificial intelligence machines would be emotionally intelligent, to that they will be able to understand human emotions and be able to reciprocate that, respond with that. That seems really interesting.
well, um, I just came back from this conference, and this was a point of discussion. I would point out that, I mean, and some of the people who are leading the research in that area where they're speaking, they're just starting to work on this. So this is hardly in, widespread implementation. It's still very much at the research paper phase. I think what it amounts to is really the simulation of human emotion. Silicon-based computers are obviously not capable of emotion. They're not capable of empathy. They're not capable of negative feelings. They're purely logical devices. So what the effort is, well, how can we kind of model some human reaction so that we create what appears to be a more effective computing program. It's like the famous Turing test, right? Which was used for many years as an example of artificial intelligence. Could you create a program that would fool people into thinking that it was a human being when in fact it was a computer? Well, that's not actually a test of artificial intelligence. That's a test of human gullibility. This is the same sort of thing with effective computing, is that we're trying to create models that appear to be more sympathetic or empathetic, but it's essentially it's a trick. It's syntax manipulation. To give you an example, I mean, when we build an algorithm, we specifically don't look at race or age or gender or sexual preference, because to do so would be illegal. But we go further and we say, well, we don't look at zip codes because zip codes may be a proxy for race.
Is it illegal to build an algorithm that looks at all these factors?
It is illegal to, well, it is illegal to deploy for the purpose of lending an algorithm that would
From that application perspective.
on those, right? So But I would say that just as a good practice, it's best to not focus on those kind of attributes. But if it was an academic question, gee, could we build a model that discriminated against people by race? Right? Yeah, absolutely. I mean, that's not hard to do. Could we build a model that discriminated against people by age? Well, we could just create a rule that says if somebody's over 55, we don't hire them, or we don't fund them, or we don't insure them.
I mean, the goal should not be to discriminate, but the goal to build such models with a desire to understand the underlying, challenges and risk and complexities. Then I think it's a fair, idea to go ahead and build such models so that we can use that intelligence to do better, in developing.
This is in the banking world. There's a concept called disparate impact, which is discrimination that was unintended on your part that occurs. And the way that disparate impact is measured is that once a decision is made without regard to race or age or gender, you then want to analyze the outcomes and see if, in fact, you have unintentionally discriminated against someone. But that's an after-the-fact measure. So the algorithm itself still has to not discriminate, but you can determine whether it's doing its job effectively by looking at it after the fact in a disparate impact study. And I think you're going to see that in many, many areas.
Right. No, I mean, I understand that from analysis and study perspective. Now, talking about the, study and for education perspective, building models, have there been any comparison of the types of technological approaches used in intelligent computing, such as constraint-based reasoning, neural networks, machine learning, and the types of problems that they could address for healthcare industry broadly, or for financial industry, if you're talking about, broad industries?
There's a great many academic papers that have been written that do exactly that go into taking a sample problem and then testing it using neural networks versus support vector machines versus expert systems, and then benchmarking all those. So there's a great deal of literature that deals with those topics, and I would always point out to people that the best approach to a problem is the one that works, and to not assume that there's any one methodology that's better than others. Case-based reasoning is something that kind of had its heyday, some time ago, along with rule-based expert systems. You really don't hear much about CBR anymore. I don't know anybody who's really working on it. People have moved on to statistical machine learning and deep learning. Deep learning is the hot topic for today. I mean, everybody's talking about it. The problem with deep learning is it essentially is a way, it's viewing the world in a very visual sense. So it works in the way that visual recognition tasks work. It's very good at capturing a complex state of pixels or luminescence values in a photograph and making sense of those things. It's not nearly as effective in a large range of tasks that are not similar to visual or speech recognition. So you see a great role or I see a great role for machine learning in self-driving cars, in music recognition. Yes. I don't see a great role for deep learning in, say, cancer diagnostics, where the average sample set that you look at has 20 records in it. Cancer studies don't have millions of records. So, and so deep learning.
We don't have that many records because there is no collective data available. I mean, across nations, there are so many millions of, cancer cases. So if everyone works together, if we have that ability to have the collective data of all nations, and all the cancer, patients and diagnoses, then we will be able to come up with something really very useful there.
Yes, if you can get everyone to agree to use the same process and normalize the data in the same way. Um,
Maybe we should develop a blockchain based system, whereas the healthcare industry has to use that, and all the information that is available, all the diagnoses that are happening without putting any human face to it, that data is available, because we should not be interested in which human has which disease, but we should be able to get access to how many cases are there all across nations, and what kind of environment that they were living in, and what kind of cancer they have developed. So there will be a lot of data available for analysis if we use blockchain and artificial intelligence together. And talking about that, I mean, you have been working on this cancer detection, and I'm sure there are a lot of others also working towards that, to use artificial intelligence towards cancer detection. But has there been any effort towards identifying deadly pathogens in the human ecosystem? Because if we are able to go at that micro level and have an ability to detect cancer using artificial intelligence, at we should be able to scan the environment very quickly, to have the sensors everywhere that uses artificial intelligence, the internet, using internet of things. We should be able to collect the data of what pathogens, what deadly pathogens, viruses, bacteria, all kinds of pathogens are out there, and when there is more, and what kind of diseases we are going to have, where is the source, what is the source. All this should be very easy to detect if we put our effort towards that.
well, I mean, I think you're onto something. I think I take issue with the easy part. Um,
Easy, if we are able to diagnose cancer, then doing this should not be that difficult as cancer.
well,
That's what I mean.
if you talk about environmental factors, though, environmental factors aren't steady state, right? So if you go into someone's home and you take an air sample, um, so you're certainly not going to see every pathogen that that person is exposed to. They may have been exposed walking through a train station. So the idea of how do we determine all the environmental exposures, that's quite a difficult task. When an epidemiologist looks at the outbreak of a disease or a cancer cluster, they'll do things like they'll take water samples from the community water, they'll take soil samples, they'll take air samples, they'll look at the food chain, they'll look at all these things. But this is not a generalized sort of thing. This is in response to a specific occurrence, and you have to tailor the collection process and analysis to that specific process. So I think it's still yes. I mean, these are very good things to work on. I think that getting to a point where we have kind of a universal database of environmental exposure is a rather daunting task, and then we have to be sure that we reach the right conclusions from the data. And to me, one of the most famous examples, there was the China study, in which in the 60s there was a great deal of data collected from Chinese health records, and particularly cancers by Chinese states. And there was a very famous book that was written by a gentleman who strongly believed that vegetarian diets were much healthier. And his point was that there are cancers that are much more likely to occur in areas where large quantities of meat are consumed. So that was his thesis. And he presented a lot of information to validate that thesis. The problem was that there were also cancers that were much more prevalent in vegetarian communities. The other part of the problem was that if you look at why people in certain areas ate a lot of meat, it's because they had a higher standard of living because they were factory workers. Well, The higher standard of living came with a much greater risk of environmental exposure to carcinogenic chemicals and air pollutants. So the fact that you saw an uptick in lung cancer in cities where people were mostly worked in manufacturing and also ate meat hardly validates the model that vegetarianism prevents cancer. So you have to be very careful about the conclusions that you draw from
Of
these
course,
things.
because see, it's not about vegetarian diet or non-vegetarian diet. It's about how healthy human body is. There are a lot of factors that come into play, So it's not just one aspect what you have eaten that makes you like that. How much stress you have, what kind of environmental exposure you have, and many other factors that come into play. So, but the fact is that with artificial intelligence and with Internet of Things and sensors that are coming across, and if we are able to develop blockchain based systems and use all this collectively together, then there is a hope that we will be able to bring such powerful difference. We will be able to solve so many big problems that nations are facing, humans are facing, and humanity is facing. So there is a lot of hope in the promise of this technological advancement. So, but let me ask you this, Mark: if you have the power to influence making artificial intelligence work for everyone across nations, where would you like to see the development happening?
Well, I'd like to see more development or an increased pace in development in the biomedical area. I think that that's the area that's going to have the greatest impact on the human condition. Um, you know, Certainly there's quite a lot of work going on with artificial intelligence in, say, ad bidding in on the internet, right? Controlling what ads you see. That's a case where there's an economic incentive to do it, but it hardly makes our lives better. Whereas in the biomedical field, I think it offers a great deal of promise for improving the lives of millions and millions of people. So that would be the area of focus that I'd like to see. I think we're going to see continued advancement in autonomous vehicles. That's probably a very big next step. I can certainly see delivery vehicles and trucks moving to an autonomous system, but it would still be with a human driver, being able to override the system. But I think that you're probably going to see more sophisticated systems that prevent accidents by potentially overriding an emission of the driver or governing a driver's ability to speed excessively, or prevent a driver from running through a red light by an override system. So I think we're going to see a lot of work in that area. Drone technology, I think, is going to continue to advance. I think probably the most important aspect of drone technology moving forward is the implementation of swarm algorithms for guidance. The notion that when birds fly, they don't use maps, they don't use GPS. They have a rather sophisticated system of measuring the distance between other birds, and you don't see them crash into each other very often. So I think there's a lot to be learned from these kind of algorithms modeled upon nature in things like flight management. The military certainly is working on a lot of applications of swarm technology, because if you could create dumb missiles that simply followed each other to a target, you could deploy many thousands of missiles at very low cost. That's not what I would have hoped for the first implementation of swarm technology, but it will have civilian application as well.
Yes, yes. So it seems now. I mean, there is a lot of research going on. There's a lot of investment going on. There are a lot of progress and advancement happening when it comes to machine learning and artificial intelligence and intelligent machines. But all that you see happening across major corporations, like Google or Facebook or IBM, or some Chinese corporations, and also some smaller corporations, and also at some universities. But do you see a possibility of effective democratization of intelligent machines, that every single human being will be able to benefit? Because at this point it looks like the people or the entities that would be able to benefit are going to be largely corporations, and the benefits probably would not go to each and every single human being. So do you see that human there will be a democratization of intelligent machines? And if not, where do you see the obstacles that would prevent the democratization?
Well, I'd want to, kind of unpack what you mean by benefit. If
So there
Apple,
are direct benefits and there are indirect benefits. Yes, they will be able to benefit from the products that come out based on artificial intelligence, but will they be able to independently benefit? It's like encryption. So far, encryption over the years it used to benefit only governments and some other corporations, but now we are at a point that each and every individual benefits from encryption technologies, which is which has its own risk and rewards. But similarly, the artificial intelligence based intelligent machines, would each and every individual human being be able to benefit directly from that?
well, if Siri makes my phone more useful for me, I derive benefit from it. You can argue that, well, that's really to the benefit of Apple from a monetary standpoint. But I think you could apply that to any product. If we enjoy drinking coffee, ultimately that profits coffee roasters and distributors and growers. It doesn't benefit us, but I still like drinking coffee. So that's part of the equation. Are we going to see a system where anyone can build an artificial intelligence tool and sell it? I think we already see that. You can, for instance, sign up for free API access at Amazon, Microsoft, Google, HP, any of these companies offer free trials for their AI platforms for experimentation to try to foster innovation. So I think anybody can leverage that and build something new and create a company that will benefit them. So I think there is democratization in the sense that a lot of these large companies are open sourcing or releasing the technology into the wild. Now they're doing it for selfish reasons. They want people to use their technology, and they want people to build tools based upon their technology, which will benefit them. But it's not like you can't work in AI today unless you go to work for Google. It's quite the opposite. Anybody can work with it.
Yes, but it's very complex. Anybody can work in it, but it's very complex. It's not easy to develop the algorithm like that. And at the same time, if everybody, democratization also brings a lot of security risk. If each and every human being is able to develop such complex algorithms which could benefit or hurt humanity, we don't know what kind of algorithms they will develop. So a lot of factors and variables come into play, but there is no question that society is shaped by advances in science and the technologies it creates, and by humans use of them. So like many other individuals, entities and initiatives, your organization is also trying to further advances in science and technology, and we thank you for that. But do you feel that the advances in science that you all are working on is a cause of celebration or a cause of concern?
It all depends how it's implemented and what it's used for. I think that there's been a great deal written in the public press or the popular press about the dangers of AI, which is envisioning something that doesn't exist. I mean, as someone pointed out, I think Andrew Nig pointed out, worrying about the dangers of AI, of a general artificial intelligence, is kind of like worrying about overpopulation on Mars. We haven't gotten there yet. It's really not an issue. And so I don't see a large-scale threat of artificial intelligence just because it just isn't that good. It's not very effective. It's like if you created a massive new weapon that could destroy everybody on Earth, that would be a great threat. But what if it didn't work? I mean, what if there was no possibility for it to work? Well, then it's not really a threat at all. It's just a perception. And I think there's this perception that artificial intelligence presents a threat, but I don't think it does. Additionally, I think that we have changes in our economic base. We have changes in our workload and workflow. And, at one point, one of the most popular jobs in New York City was honey wagon driver. That is, people who rode around and shoveled up horse manure, because it was a massive amount of horse manure being generated in New York before the advent of automobiles. With the advent of automobiles, there was no need for honey wagon drivers. So we did see, there was speculation that, oh my God, these thousands upon thousands of people were all going to starve to death because all they know how to do is shovel manure. Well, somehow the advent of automobiles didn't destroy the economy of New York. The people who used to shovel manure moved on to do other things, and the technology improved the overall state of New York, or the state of life. In the same thing, when we talk, like today, we have this argument about coal miners are being put out of work, right? Well, coal miners are being put out of work because there's no clean way to burn coal, and coal is a massive cause of pollution, and we simply can't afford to be burning it for the generation of electricity. So we have this situation where, well, are we going to be unfair to coal miners who want to continue mining coal? Are we going to be unfair to the rest of us who need to breathe? Well, we have to look at the overall benefit, and we have to find ways to transition coal miners into other forms of employment that aren't environmentally damaging. But that's, when we talk about doing away with coal mining, we're not talking about doing away with coal miners. We're talking about repositioning them into other fields, retraining, redeployment. So I think the technology works the same way.
Yes, very true, very true. So, Marc, thank you so much for participating in the Risk Roundup today. We appreciate your thoughtful insight on artificial intelligence, machine learning, and intelligent systems. And I'm sure our global viewers and listeners will benefit tremendously from the understanding you provided on the application of intelligent machines across several industries, from financial industry to healthcare industries, and the opportunities and risk associated with the advances in technology and non-human intelligence. So even if a single individual or entity is able to come up with ideas to advance machine learning, innovate to develop intelligent systems for the complex challenges facing nations, and manage its associated security risk based on the understanding they received from this discussion we had today, this Risk Roundup dialogue has been of service, and we thank you for that, Marc.
Thank you very much. I've enjoyed it. It was great to talk to you.
Wonderful, Marc. So as all forms of computers and machines are getting faster and more powerful due to advances in artificial intelligence, and they acquire an ability to think, it is important to evaluate whether artificial intelligence is the next step in our human evolutionary journey. Now, considering that it is the next step in our human evolutionary journey, it is important that we evaluate and understand the impact it will have on each individual and entities across nations, its government, industries, organizations, and academia. As the evolving story of non-human or machine intelligence and intelligent computing brings advanced algorithms, pattern matching, rules, machine learning, deep learning, and cognitive computing to solve problems typically performed by the humans. The concerns that in the coming years, human intelligence systems will not be able to solve complex problems surrounding them in cyberspace, geospace, and space on its own is getting very real. Risk Group Cybersecurity Risk Research Center and Strategic Security Risk Research Center are created for this very reason to identify, evaluate, and manage the risk facing NGIOA in CGS, that means nations, its government, industries, organizations, and academia in cyberspace, geospace, and space, and discuss, debate, and define necessary framework, structure, processes, tools, and technologies to manage the security risk of not only the digital global age, but also of the coming technological superconvergence. We at Risk Group believe that risk management, security, and peace walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. It is not possible to conceive any one of the three without the existence of the other two. All three concepts feed into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security, so if we build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the risk roundups, to watch the risk roundup videos, or hear the Risk Roundup podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayshree Pandya, host of Risk Roundup, signing off. See you next time. Thank you.